Alright, so in this video, I'm just going to quickly walk you through the circuit that we built today and then walk you through the code. If you need to pause it, feel free. If you need to rewind, feel free. I'm going to try to go nice and slow so that you can kind of see what's going on and that it doesn't get confusing. But again, if you need me to slow down, then you can just rewind. If you need me to stop, you can just pause. So hopefully this helps out those who maybe weren't able to get the circuit complete today. Okay, so first things first, let's talk about the pull-down resistor and the button. So, got a couple things going on here. First is that this button is connecting this 10 kilo ohm resistor. And it's connecting this button through the 10 kilo ohm resistor to our negative power rail, which is then connected to our other negative power rail, which is finally connected to the ground, which is the negative battery. You can think it's the negative on the battery. Okay, so we've got that going on. The other thing that we've got going on is that this other leg that's connected to the resistor, that's connected to the negative, is normally connected to pin 2. So this is connected to the ground. Pin 2 normally connected to the ground, and that's when the button is not being pressed. So when the button's not being pressed, remember, terminal 2A and 2B, those are connected together. So that means that this pin 2 is connected to the ground. Okay? So that would read a voltage of 0, which is what we want when the button's not pressed. Now, if you look at the other part of this, you can see that the other part is connected to the 5-volt power source. So this is just like a 5-volt battery that's continuously giving out 5 volts. Okay? So you can imagine that when this button is not pressed, the 5 volts is not completing any circuit. There's nothing connected to the other leg here. Okay? However, when this button is pressed, now terminal 1A and 2A are connected, which means that this 5 volts has the option of either flowing to pin 2 here or to the ground over there. And because with electricity, it wants to take the path of least resistance, it's going to go through this yellow wire to pin 2 instead of going to the ground. And the reason that it's going to do that is that this way has 10 kilo ohms of resistance. So if it wants to go on the path of least resistance, 10 kilo ohms is a lot more than 0. There's no resistance in here whatsoever. So the electrons, instead of going left, will go to the right and will go to pin 2. So this 5 volts is basically then connected to pin 2, which will record a 1 as high. Okay? And then the other part that's relatively easy here is our RGB. So you can see that each of these pins represents a different part. So we have 3 colors, a red, a blue, and a green, and then we have the cathode. So the cathode, remember, C needs to get connected to the ground, which is the negative, and that's connected to the ground there, so that's good. And then each of our different colors is connected to a different pin so that we can use each of these pins to turn on or off that color. Okay, so that's it. That's pretty basic circuit, nothing too crazy. The crazy stuff comes when we get to the code. So let's go ahead and dive into the code. Take a look at this. Okay, so we have to start by actually declaring this variable. So anytime you're doing coding, you need to declare a variable. By declaring it button state, that's just a name, that tells us what this variable is going to be holding. So it's going to be holding the value that's read at pin 2. This value that's read at pin 2 can either be a 1 or a 0, a high or a low. And you're going to see where that's going to come in later on in our code. Okay? Now, the next part is our void setup. So notice it starts with a curly bracket and it ends with a curly bracket. Okay? In addition to that, we have all of our pins that are being used set up in this little block here. So we have pin mode 2, that's being used as an input. Pin mode 8, that's being used as an output. Pin mode 9 being used as an output, and pin mode 10 being used as an output. Okay? So that's all we need in our setup. We've declared all of our our variable, and then we've set up all of our pins. Okay, so then we can get down to the void loop. And in this void loop, the first thing we need to do is assign our variable that we declared up here. we need to assign it some value, because right now this doesn't have any value at all. It's not 0, it's not 1, it's not anything. There's just no value for this button state. So the first thing we're going to do is we're going to give it some value. What value are we going to give it? Well, we're going to read the voltage at 2, and that's either going to give us a 1 or a 0. So if the button is not pressed, we're going to have a voltage of 0, so we would get 0. If that button is pressed, we would have a voltage of 5, which would give us a 1. So then we can actually go and we can use things. So we can say, all right, this if statement. So if this condition is met, then it's going to run this block of code. If the condition's not met, then it's going to run this block of code. Okay? All right, now, I first did this in the lesson. I only had one of these digital writes, so I only had like either green or blue on. But by doing both of these digital writes at the same time for pin 9 and 10, I'm actually sending this color and this color at the same time. So I'm sending blue and red at the same time. If you remember from class, blue and red together makes purple. So if the button is pressed, so if the button's pressed, then that'll give a digital signal of a 1. Then it's going to do this. What's it going to do? Well, it's going to digital write, so it's going to send a signal to pin 9, and it's going to send a signal to pin 10. If it does that, that should give us a purple light. Okay? So that's what this first if statement is, and notice that it starts with a curly bracket and it ends with a curly bracket. Just like our void setup starts with a curly bracket and ends with a curly bracket. Same thing with our void loop. Starts with a curly bracket, ends with a curly bracket. Okay, well, what do we want to happen if that button's not pressed? Well, we want the lights to turn off. How do we do that? Well, we just digital write to that pin, but we send a low signal. So the low will turn it off. And we have to do both of those at the same time to make the lights turn off at the same time, so we don't see like a flicker. And then remember, you need the open and close for each of these functions. So else, open, this, close. And then finally, we have this last close bracket. And that is for our void loop. So when we run this, we should see that when we press this button, it turns purple. And that's exactly what we want. If we let go, it turns off. So on's purple, off is clear. Okay, so make sure that you have this code, this circuit, make sure it works, so that in our next lesson, when we start talking about analog inputs and outputs, you have something to compare to. So we were talking about digital today. Remember, digital is either a 1 or a 0, and that's all it is. Analog, we're going to get all of those numbers in between. All right, hopefully this helped. I will see you all in class later this week.